Hi everybody, this is Mr. Newberry. This is your 1.4 lesson for Unit 1 in Geometry and Honors Geometry. So today I'm going to start off by actually showing you how you're going to access your assignment. And I'll go back to this right at the end to talk about it again. But I'm going to share with you guys a link, right? And when you click on that link within Google Classroom, it's going to take you to GeoGebra Classroom. Right, it'll take you to this page right here, and all you have to do is type your name in and click start. Right, now this isn't an account you're going to be able to go back to, but as long as you stay on this page and work through this assignment, it'll stay under your name. All right, so I would advise that you, when you're doing this, you make sure you're sitting down to work on the assignment. You work on it all the way through, and if you need to do it again, by all means do that. Just make your name and maybe put your name and number 2 if you want to try it again. But the way it's going to work is there's going to be 7 different things, 7 different activities that you have to complete within this assignment. And as you're completing each assignment, all right, I will be able to see your progress and what your finished outcome of each one is. Okay. Now we're going to go through all 7 of these in 2 ways. We're going to go through how you would do these basically in the real world using a compass and a straight edge. And we're also going to talk about how you can do these in GeoGebra, which this entire assignment is in GeoGebra. So the video I'm showing you right now, you could use this video and copy every single thing I'm doing to complete these assignments. And I'm perfectly okay with that because I want you to get the practice of not only using GeoGebra, but also understanding how the tools work within GeoGebra and how they compare to real world tools like a straight edge, a compass. Eventually, we're going to be working with protractors, rulers, things like that. Okay? So follow along as I go through the real world and then we transfer it into GeoGebra. All right? So for our real world, we've got a little app here that actually goes through exactly how it's done in the real world. Now I'm going to do this one step at a time. Now, the first thing we're going to be working on is copying a line segment. And you're going to be given a line segment. And in order to copy it, you need a starting point. So point R is where we're going to start our new segment at. And we want our new segment to be the exact same length as segment PQ. Right? Now this tool that just popped up, this is a compass. Right? In real world, that edge, the end that's on point P, that would be the sharp end that is stationary. And then this yellow stick on this end, that's the pencil. All right? So this is the end that stays put, and this is the end that moves. All right. Now a compass can be used to draw circles, okay, with the center being where the sharp end is. It can also, you can draw arcs, which we're going to see some arcs in this one, in this applet. And it can also be used to measure distances, okay? And that's the first thing we're going to do. We're going to measure the distance between P and Q. When I go ahead and click next, we're going to move that down, and we're going to draw an arc that's the same distance as the distance from P to Q. Now, essentially what that arc is, that's a small piece of a circle that has a radius from point R to all of the points on this arc. Excuse me. Phew. Bless me. So that's just a small arc of that circle. You'll see in GeoGebra, we have to draw the entire circle, okay? But that's just because of the way the app works, all right? Now, to get a congruent segment, we need a point on this arc. So we have point S, and last, we have to draw between point R and point S to get the segment that's the same length. And we use a straight edge to do that. Okay? So this is how we would do it in the real world with a compass and a straight edge to get a congruent segment. Let's take a look at how we would do this in GeoGebra. Copying a line segment's the first thing. All right? It's going to take a second to load up. Spinning right now. Should end up in something we can click in the middle, or it might just pop up. Hopefully it just pops up. Give it another second here. Make sure I'm connected to my internet. All right, come on, internet. All right, we got the internet working again. All right, here we go. So again, we were in the GeoGebra app. When I clicked on copying line segment, this is the thing that popped up. It says, given line segment AB, copy it to the dotted line as shown in the applet. All right, so here's what we're going to do. We are going to copy a line segment so that it lays right on top of this red line. That's the goal. Now, just like in the real world, we're going to use a compass to measure this length. And this is the compass tool right here. It's the red circle with the little segment underneath it. So if I click on that, I'm going to go down to compass. All right. Now, the pointy end is always going to be the second click. So the first click is going to be the outside of the circle. The second click is going to be the pointy end. And you'll see what it does is it makes a circle that has a radius the length of the segment of AB. Now what I'm going to do is I'm able to then move this circle around. Okay? And the nice thing is it'll lock in. You can lock the center when you get close to points. And I want to lock that center right on point C down here. And once I'm there, I can click it and it becomes stationary. All right? So now I've got a circle with a radius that's the exact same length as the segment AB. So now I know that from point C to the circle is the same length. So I'm going to go ahead and put a point right there. So I got to go up here to point. And I click on the circle right there where that point is. And I've got a point. All right. Now to complete this, I need to draw the segment. So I go up here to segment. And I click 2 points that are the endpoints. And it should pop up right there, well done. If you got well done, you know you did it right. Okay. Now I want to leave my page looking like this, completed. Okay, you want to leave it completed. And here's why. As a teacher, I'm able to go in here and look under our class at the tasks that have been done. And if I go to task number 1, there we go. If I go to task number 1, now I did a test earlier. Now I did one with Mr. Newberry because that's what I typed my name in as. If I click on it, I can see what your finished product looks like and if you did it correctly. All right. So I should see the circle. I should see the segment. I should see that it's the same length as AB. All right. So this is what I need, and this is what I'm checking your work with. All right. So I should see something that looks very similar to this. All right. Now, if I go to task 2, we're going to move on to task 2 in a second. I'll see your work there in task number 2. All right. But let's go ahead to our second one, which is going to be a midpoint. Now, this applet's called perpendicular bisector of a line segment. Well, a perpendicular bisector is the exact same thing as a midpoint. All right. Because it's bisecting the line segment. It's cutting the segment into 2 equal segments. That's what a midpoint does as well. All right. So let's see how this looks. So I'm going to click reset. All right, so we start off, we got a segment, okay, segment PQ, and we want to find that midpoint, the exact middle point between P and Q. So the first thing we're going to do is we're going to reload this applet because this one seems to get a little messed up the more we do it. All right, let's try it again. So we got a segment. There we go. Well, you're going to take the compass, all right? Now it says adjust the compass to just over half the length. I'm going to recommend when we do GeoGebra that you go from one endpoint to the other, all right? But you'll get the same solution here, okay? Because what we're looking for is we're looking to make 2 equal, basically exact same size circles that overlap, all right? So they do one above and one below. Then they're going to move the compass. They're going to leave the compass the same length, so it's the same size circle, but change the center to point Q. And they draw the lines above and below where they intersect. And what we have now is we have 2 points that if we connect the 2, right, gives us a point on the line, right, in this case point J, which is exactly between P and Q, the midpoint, All right, point J would be the midpoint. All right, let's see how we're going to do this in GeoGebra. All right, so now that I've finished task 1, I go to the next one, midpoint construction. All right, now here's my segment, A and B. Now what I need here is I need 2 circles. Now we could do compass, all right, but we really don't need to move our circles around. So I'm going to go ahead and click on this second one. This is just a circle with a center through the point. All right. Now what I'm going to do is I'm going to select a point. In this case, when you're on this tool, the first point you click is the center, and then as I go out from it, you can see the circle gets bigger. Now I want one that's a specific size. I want it to be the same length as the segment. I want the radius to be the length as the segment. Click second time, it gives you your circle. I'm going to make another circle with the same radius, but the new center will be at point B. I go from B to A. Now look what happens. We've got our 2 lines here, our 2 intersection points. Right? We've got our 2 intersection points, one above and one below the line. I'm going to go ahead and make a let's see, I'm just going to do a segment. Actually, I'm going to do points first because I want the intersection. I want the points where these intersect. So I'm going to put a point there, point C, and point D. Now I'm going to make a segment between those 2 points. So I click on C and D. Now I'm not done because all I did was find a line and I know where that point is, but I have to make the point. So I click on point again. And I click right there between A and B, and I get a pop-up here. It says awesome. Okay, you want that. If you did that, you know you got it right. Right? And there is point E as my solution. Okay. Now again, you want to leave it like this because when I go back to my page, now there is Mr. Newberry's solution. All right, with the point. If I click on it, I can see it exactly where you're at. All right, good. Next one is going to be, let's see, perpendicular through a point on the line. All right, so I'm going to click next, but I'm going to go back to the real world one first. 1, 2, 3, perpendicular at a point on a line. So I'm going to go click next. So I've got a line. This goes forever in both directions, and I got a point K. I want to draw a perpendicular line that goes exactly through that point K. So the first thing I'm going to do is with my compass, right, or in our case in GeoGebra, we're just going to use a circle tool. We're going to draw a circle where the center is point K. In this case, they're just drawing the arcs because we're only really concerned about the places where they cross the line. What we've now made is we have a segment PQ where P is one endpoint, Q is the other, and K is exactly in the middle. I know it is because these are the exact same radius lengths from K to Q and K to P. All right. Now from here, I'm going to do the exact same thing that I did when I found the midpoint. All right. I'm going to go ahead and take this. Now they extend it just longer than halfway, but I'm going to do the full segment length. They make an arc, one arc above, a second arc above. In GeoGebra, it'll be 2 full circles. And to get our perpendicular, they draw a straight edge between the 2, right? And it'll make a 90-degree angle with that line and our given line that goes through point K. All right? Let's see how we do this in GeoGebra. So in this case, we're given a line, and we are given point P. Okay, point P is the one we want to go through. We want a perpendicular that goes through point P. So the first thing I'm going to do, I'm going to go with just a straight circle because all I want is a circle with P at the center. All right. Now I click just off the line. If you click close to the line, you can get confused as far as where that is. Let me go back and do that again. All right. It may even be better to point it down here because wherever you click that second point, it does put that point in your graph. Now what I'm looking for, I need these 2 intersection points. All right. If you're concerned, if you really want to see those points, you can go over here to either intersection or point tool. I'm going to click intersect. And as long as I'm close to those places where they intersect and click my button, it'll put a point where the circle intersects with the line. All right, those are important because I got to use those two intersection points because they're going to be the center of my next two circles. So I'm going to click here. I'm going to make a circle with a radius of the segment length. Then I go over and have another center over here. Make my circle with the same radius length. I'm going to go ahead and zoom out a little bit so we can see everything. Now, if I were to draw from that intersection point to P and make a line, it should be perpendicular with the given line, right? But I want that intersection point first. So I'm going to go over back up here to intersect. Click right about, there we go, right where those two circles intersect. Now I'm going to draw a line between these two. All right, let's see here. I'm going to go, there it is, line. Now I've got some options here, but I really want line because I want a line that goes from there to there. Now it says nailed it right there in the middle. You know you got it, okay? If you see that nailed it in there, you know that you got the right answer. Again, leave it like this. So when we go to the next one, that'll be there for me to see. As a teacher, I know you did it right, okay? But again, I want to see all these things. I want to see the circle where you got endpoints. I then want to see the two big circles with the intersections, all right? And your line that you're drawing from that intersection to point P. All right, 4 more. Perpendicular line through a point. I'm going to go ahead and click next so we're at that next one. But now you see we're doing a perpendicular line, but it's got to go through a point on the outside. Okay, real world here. So we're given a line and point R is above it. We're going to take a compass, and we need that compass to be longer than the distance from the point that's above the line and the line. So we're going to extend it past the line, and we're going to draw a circle or an arc that intersects the line in two places. Now what's nice is we know that from R to P and from R to Q, that's the same distance. Okay, same distance. And really what we've found again is we have found the endpoints of a segment, and we're going to find the midpoint between them, which we've already done before. Okay, so we're going to do the same process. We're going to draw those arcs from the new endpoints we just made. Okay, we know that these are the same distance away. And then we're going to connect this intersection point with point R, right? And that'll give us a perpendicular line that goes through not only the midpoint, but also is perpendicular to line PQ, line PQ, right? Go ahead and finish this out. And we got it. Okay. In GeoGebra. All right, so we got same idea here. We want to take a circle tool. We want to draw a circle with the center at point C. It's got to go below the line here, okay? Now you can make it not very far, or you can make it bigger. I'm going to put it kind of about this distance, right? I then want some intersection points, all right? I want the intersection where the circle meets that line. Now I'm going to go ahead and do the circle tool again. I'm going to make a circle that has a radius from this endpoint to this one, and going the other direction, this endpoint to this one. So I've got two circles that are identical in size, right? I know they're identical because they have the same radius, right? And I can now, if I were to draw, I'm going to go ahead and make these intersection points here and down here. If I were to connect these two intersection points with my line tool, so I'm going to go from here down to here, it should go straight through the midpoint of our blue line and through the midpoint and should be perpendicular. And I do see a little nailed it pop up there as well. All right, so we got that one correct. 3 to go. All right, so our congruent angle construction. So we're gonna be given an angle. We got to draw one that's congruent to it. All right, so we're given an angle, in this case, angle BAC or angle CAB. Okay, to draw a congruent angle, we're going to need a ray to start with. Now, in this case, they draw a ray there, and it's ray PQ. right? So we want to have an angle that's congruent to the initial one. So what we're going to do is you're going to take your compass and you're going to draw an arc, okay, that intersects at two places, right? And that arc would, in this case, intersects at point J and point K, right? It's important that you use the same, in our case, it's going to be nice in GeoGebra because it's the same circle, but those two intersection points are going to be key. The next thing we're going to do is draw that same arc over here on our new line, all right? After doing that, we go back. You are now going to measure from those two intersection points, and you're going to draw, okay, an arc up. So we've basically got an intersection. You've got on the top left, by measuring that from K to J, okay, we then go down to our new line, and where they intersect is the same place that J and the arc intersect in our initial angle. So to get our solution here, to get our angle that's congruent, all we're going to have to do is connect P through L, and we've got our congruent angle. All right. So again, this one's pretty straightforward. It involves one arc here and then another arc here, and then you have to connect the dots to get your congruent angle measure. All right, let's go look at GeoGebra. So we've got our initial angle up here. We've already drawn the ray down here on the bottom. So I'm going to go ahead and start with I'm going to go ahead and do our compass tool because I'm going to want to move this. Okay, so I've got to do this twice. I'm going to first click. Nope, I clicked on the wrong place. So I'm going to draw this, but then I'm going to undo it because I did it wrong. Undo. All right, let's try this again. I'm going to go ahead and put a point on my circle here. I'm going to make it a little bit closer. So we'll make it right there. Now I'm going to go to my compass, and I'm going to click J first and A second. All right. Now what I have here, all right, is I know I've got a circle, all right, that is a compass, so I can move it, but I know it's the same length from A to J. That's what the radius length is. I'm going to go down here, and I'm going to move it down here. So I know that if I put a point, actually I'm going to do the intersect tool just to make sure I'm on the intersection. I know that that point K, from D to K, that's the same length as A to J. All right. Next step, I need to take, well, you know what? I need to do another, I'm going to do another compass here. And I'm going to go from J to A again. But I'm going to click right away. So I've got these both here now, right? And the reason I need that is because I need to know this intersection point up here. So I've got my intersect selected again. I need that intersection point, right? Because I'm going to need to figure out the compass length from J to L and then bring that back down here to get the same thing. So I'm going to go back to my compass tool. I'm going to go ahead and click from L to J. Okay, remember when you use the compass tool, the second button you click is the center of the circle, and you'll see that right where L is crossing with the other circle, all right, that is going to be the come back. Right where L crosses, all right, that's going to be the point I need when I move it down here. So instead of the center being on J, since I'm in compass, I'm going to drag it down and put it on K. I've got an intersection right here. All right, let's go to intersect, put a point in, and now I just need to make a ray, because remember, rays are what make up the sides of a circle. So I then go up here and go down to ray, and I go from D through M. Nailed it. Okay, I've got my congruent angle. It's congruent to angle LAJ. We have congruent one MDK. All right. Again, leave it like that. That way it's good to go when it's time for me to look at it. Angle bisector construction. Now we're going to bisect the angle. We're going to cut this angle in half. All right. All right. Real world. Here we go. We've got an angle. We want to bisect this angle. We're going to take our compass. start off the same way, right? We got to then make an arc that's going to intersect the two rays at the same distance from the vertex, right? Similar to how we started the last one. What's going to be different now is when we measure, right? Now I'm going to show you guys, I'm going to have you guys measure from those two intersection points from here and here. You're going to get two circles with radiuses that are that length. In this case, it's a little bit bigger, but it gives you the same, you can get the solution this way as well, right? But you got to keep those circles the same length, and you've got to draw a point of intersection, right? When we do that, it gives us a point that when we draw from the vertex through that intersection, we are drawing a bisector, okay, a ray that cuts the big angle into two smaller but congruent angles, all right? In GeoGebra, same idea. We're going to draw, first of all, we're going to draw a circle. Okay. Again, does not matter. There's nothing. What happened there? Got a quick click. It doesn't really matter how big the circle is, but we don't want it huge. We don't want it small. I'm going to make it a middle length, about this big. All right. Now I need those intersection points. So I'm going to go back up here to intersect. Click on those points of intersection. All right. Now I'm going to go to circle with a center. I'm going to draw two circles with the same radius. I want those radius lengths to be from F to G. So my first one I'm going to have centered at F. And the second one I'm going to have centered at G. Now this point right here, that intersection, that's the key to this. If I click on that intersection point, sometimes if you click on it, it fuzzes up like that. Whatever one's fuzzy, just click on the other object and it finds the intersection between the two. I need to draw a ray from A through I now. All right, so I go back up here to my line tool, down to ray, and I click on A because that's my starting point. Click on I because that's what it goes through. Nailed it. Got it right. Okay, that one shows the ray that bisects the angle. And yes, they look more confusing the more we do these, but again, I'm looking for these circles that you're drawing because that's showing me that you are constructing it correctly. All right, one to go. All right, equilateral triangle. So how to make an equilateral triangle. So you start off and you've got a segment. Now, I like to draw a horizontal segment to start, but you can do a vertical one too, all right? Now, what we've got here is we're going to be making, basically, they were drawing an equilateral triangle with side lengths that are the same as AB. We're going to be constructing one where AB is like horizontal, and that's going to be one of your three sides. But essentially what we're doing is we're drawing a bunch of circles here, and you'll see how they work out. It's pretty cool. And what we've actually drawn to start off, like we know that P was the center of a circle, and these are just two arcs. And what's nice is any point on this arc is going to be the same distance as any point on this arc. So by putting one point over here, we know from P to Q that's the same distance. We keep the compass the same distance, and we make another arc up here. We now know from P to Q that's the same distance, from Q to R that's the same distance, and since we made an arc initially from P to R, we know that's the same distance, okay? By connecting all the dots, we get an equilateral triangle, okay? In GeoGebra, I think it actually looks pretty cool when we do this. All right, so leave this, go to equilateral triangle. So we're given AB, right? Here's what we're gonna do. We're gonna make a circle, okay? We're gonna make a circle that has the same radius. It's gonna be the distance from A to B. So there's one circle with A at the center. There's a second circle with B at the center, right? And what's nice here is I know that this intersection point, intersect, right? I know that this intersection point, that is going to be, let's do segment, the same distance to A and to B because it's the same radius length, okay? And because it's the same radius from A to B, we know that all three sides are the same, right? Now, I like to draw, just because I think it looks cool, I like to do this final circle as well, right? So you got like the, I didn't mean to do that last one. What is that? Like the radioactivity symbol kind of looks like, right? But again, I want to see these, at least the first two circles made, right? Showing me that you found the intersection point and then connect the dots using the segment tool, all right? That covers all of the real world and the GeoGebra constructions. Just remember, I will be posting this link, all right, to your Google Classroom assignments page, classwork page where your assignments are, right? You just need to click on that, put your name in, and then work through the assignments. If in another window, if you want to have this video up and running, by all means, do that, okay? But again, you'll see that all of these tasks that I have been finishing all stay up here, and this is what I'm going to be going through to make sure you completed all the tasks to give you the full credit, all right? So 7 constructions, 7 for you to work on. This assignment will be due on Friday the 11th, so you're going to have a week to complete the assignment, but you should be working on it earlier than that, okay? You should be working on that assignment over the weekend, early next week, making sure that you're getting it done. If you can get it done before our next class meeting, which is either going to be Tuesday or Thursday, that'd be great. We're going to be posting our review for the first unit test, probably middle of next week, all right? So I don't plan on talking about constructions the entire 50-minute Zoom session. We'll probably start reviewing for your test as well. But I want you guys to be working on this. And if you are having problems with it, you will have till Friday to get it done. All right? You guys have a great day, and I'll see you next week. Enjoy your Labor Day weekend.